Okay, that's my cue. Okay, good evening. We are so glad you joined us for Lost Connections, uncovering the impacts of nearly lost keystone species on grassland ecosystem health with Andy Boyce-Pero, who is an avian ecologist with the Smithsonian. Now, my name is Ann Reddy, and I am chair of the Gallatin Valley Earth Day Committee. And tonight's talk is the fifth and last in our series of talks for this year. The talks have been running from January through April, leading up to our annual Earth Day Festival and 5K Earth Day Fun Run, which are both taking place at the fairgrounds here in Bozeman on Saturday, April 25th. If you would like to watch a recording of a past event or you would like to find out more about our upcoming events, please visit our website at gallatinvalleyearthday.org. Now, before I turn the live stream over to Andy, I just would like to take a moment for a few thank yous. Our whole series of talks is free only because of the very generous support from businesses and organizations in our community. So I would like to thank our fiscal sponsor, Greater Gallatin United Way, and our premier sponsors who are sponsoring the whole 2026 series, Toyota. They will be featuring their Toyota BZ electric car at the Earth Day Festival on April 25th. Also, Bozeman Greenbuild, you can also find them at our Earth Day Festival. And Yellowstonian, if you haven't checked them out yet, it's a great, wonderful online magazine that has great articles about wildlife and other concerns that deal with the greater Yellowstone ecosystem. And then last, Montana Parent Magazine. And then I also want to give a great big shout out to Gallatin Wildlife Association here in Bozeman, who is underwriting this event tonight. And of course, all of our community volunteers who make these events happen. Now, before I switch over to Andy, I also wanted to let you know that you will have a chance to ask Andy questions once he's finished his presentation. For the Q&A session, if you look at your screen, the Zoom screen at the bottom, it says Q&A, so just click on that, and then a box will pop up. You can type in your questions, and then I will read your question to Andy. So now it is my great pleasure to introduce Andy Boyce-Pero. Andy is a research ecologist with Smithsonian's Great Plains Science Program, and he is one of the founding members of the team, and he has been a part of that project since 2018. His work focuses on one overarching theme: understanding how to most effectively conserve imperiled grassland birds and their habitats. Now, sometimes this takes the form of cutting-edge tracking studies, sometimes old-school point counts and nest searching, or even, I find very interesting, piloting remote-controlled badgers to understand how birds respond to potential predators. Andy received his bachelor's degree in ecology and evolution from the University of Colorado and his Ph.D. in wildlife biology from the University of Montana. So I will disappear now and let Andy take it from here. Thanks, Andy.
Hi, everyone. It's spectacular to be here with you all today. I thank everybody who's joining us for coming in out of what, at least here in Missoula, is a spectacular spring day. The sun is out, snow is on the mountains, so thank you for choosing to spend your time with us. I want to talk to you about what I'm calling lost connections, uncovering the impacts of nearly lost keystone species in our grassland ecosystems. If you're willing to indulge me for just 5 minutes, I want to explain to the group, what the Smithsonian Institution is and what we're doing here in Montana. So the Smithsonian is the world's largest museum, education, and research complex with 21 museums, 14 education and research centers, as well as the National Zoo and Conservation Biology Institute. The mission of the Smithsonian is simply the increase and diffusion of knowledge. And frankly, this gives us a tremendous amount of academic freedom to pursue topics that we believe are important to the American people. and mandates that our work reaches the general public through education and outreach at every opportunity. I'm sure that the many iconic museums on the National Mall in DC are what most people associate with the Smithsonian, and for good reason. You know, millions of visitors per year visit these museums, like the National Portrait Gallery, to the Museum of African American History and Culture, to be inspired and to learn about the past, present, and future of the United States. So I work for Smithsonian's National Zoo and Conservation Biology Institute. Many of you will know the zoo as a place to see and learn about animals and biodiversity issues from all over the world. But we're more than that. The zoo also houses a large group of dedicated conservation scientists tackling the world's most pressing conservation problems all over the globe. And so that brings us to Montana today. In 2018, the Smithsonian initiated the Great Plains Science Program to help address the conservation challenges facing Great Plains grasslands and to find solutions for the wildlife there and the people that rely on them. So, as an avian ecologist, joining up with this initiative in 2018 was in some ways good timing. This was around the time that multiple large studies had just come out detailing the alarming declines in grassland and grassland birds across North America. As you can see in this figure here, across all the different groups of birds in North America, from Canada to Mexico, grassland birds, along with aerial insectivores, are the group declining most rapidly. And this pattern holds across different varieties of grassland wildlife, not just birds. In fact, temperate grasslands are the most imperiled ecosystem type anywhere in the globe. And that's due to a combination of two things. You know, number one, we're losing grasslands at an incredibly fast rate. And number two, grasslands are the least well-represented ecosystem type among protected areas globally. So we know that the primary driver of grassland loss is conversion, plow up for agriculture. This isn't just a historical problem, and that's important. Almost 2 million acres of grassland were plowed up in 2022 in the Great Plains, and that pace likely continues until today. But there have been big changes on the remaining grasslands as well. We've lost, or as my title sort of suggests, nearly lost many previously ubiquitous important grassland keystone species. Tonight, I'll focus on two of those, the North American bison and black-tailed prairie dog. So the causes of these absences and declines are not a mystery. They're summarized elegantly, if not pleasantly, by this visual representation of manifest destiny called American Progress, painted by John Gast in 1872. As we're all aware, Euro-Americans pushed west during the middle of the 19th century. And the picture you see here is unfortunately fairly representative of what that looked like. Native American peoples were persecuted, driven from their lands, and had their culture, in many cases, purposely erased. Native animals like bison, wolves, and grizzly bears that were once widespread in the Great Plains were driven from those systems into the sort of montane refuges like Yellowstone Park, where we know them from today. And large, massive expanses of tall to short grass prairies across the center of the continent were converted for economically productive row crop agriculture. Now, for the species we're talking about today, this is the reality of what that meant. Over the course of just a few decades, we went from approximately 30 million bison in the North American Great Plains down to something around 30,000 today, not counting domestic animals. Through purposeful eradication and nowadays organized resistance to their restoration. For prairie dogs, they now occupy less than 5% of their historic range across North American grasslands. Prairie dogs have been and continue to be eradicated as agricultural pests and now face huge additional headwinds due to the accidental introduction of sylvatic plague from Asia in the 1950s. So, to me, I think studying these animals and understanding their role in grassland ecosystems is critically important for a couple reasons. One is that the speed at which they were eradicated means that their ecology and their overall place in the Great Plains ecosystem are largely unknown to Western scientists. And second, the fact is their restoration at large scales to this point has been largely unsuccessful and remains controversial to this day. So knowing the facts about exactly what restoring these species would mean is important to everyone. So let's start with bison, our national mammal and an iconic symbol of Western North America. As I've said, these animals are mostly gone and almost entirely replaced in the Western Great Plains by domestic cattle. What has this change meant for grassland wildlife, and what might restoration be able to accomplish? Why might we expect bison to have different impacts on the ecosystem than cattle anyway? Well, let's start with bison physiology. Maybe their most defining characteristic is their ability to withstand extreme weather conditions on both ends of the spectrum, born from a long evolutionary history in the harsh environments of the Great Plains. To put it mildly, bison are very cold tolerant. This is data that I'm showing here from a very cool experiment done by a gentleman named Christofferson in 1978. He was interested in the sort of differential physiology between a bunch of different bovids, yaks, bison, and a variety of cattle. He was interested in understanding the differences in their thermal physiology. And I found his findings just, absolutely fascinating. So first of all the types of bovids that he measured, bison had by far the highest values of total thermal insulation in winter. And bison's lower critical temperature, which is, to you and me, is essentially the temperature at which they have to start shivering to generate additional body heat. You can see here highlighted as less than negative 40 degrees Celsius. Well, why just less than 40 degrees? Why not some specific value? Well, the answer to that is that bison are very, very cold tolerant. In the experiment that they did, they were placing these animals into, cooled chambers and measuring their energy expenditure and respiration. And they came across a real problem that's highlighted here in this portion of the paper. And that is that since bison calves were still not below their critical temperature at even 30 degrees Celsius, it was impossible to determine their true insulative values. So that means they were not able to bring the temperature low enough to elicit any sort of energetic response from bison, which is really incredible. So how did these physiological differences scale up to, their behavior and the ways that they interact with grassland landscapes? Well, we know a fair amount about this from a variety of studies, a few of them here in Montana. One fact is that bison spend significantly less time at water and in the shade in compared with cattle. And those differences become magnified at especially high temperatures. And this is obviously critically important as temperatures both in spring, summer, and fall continue to increase on the Great Plains, and grazing animals are going to be exposed to higher and higher temperatures. You can see from the figure on the right, this is the estimated cumulative number of hours at which animals are above the temperature threshold where they start to seek out water. And for cattle, that's on the order of thousands of hours a season where they are really, really tied to water because the temperature is so hot, which is much less the case with bison. Consequently, bison use wet areas, so streams, stock ponds, rivers, wet meadows that are important to so many wildlife. Bison use these areas less than cattle. And you can see these probability of use curves on the left. Cattle are really spending the vast majority of their time, and ranchers will know this, very, very close to water, much different in heat and drought tolerant bison. Additionally, going beyond physiology a little bit here to dietary preferences, bison are really grass specialists. Now, that's not to say that in certain situations where grass is low or stocking rate densities of bison are really high, they may eat other things, but really when they have the option, their preference for forage is grass. And that's significantly different than domestic cattle. Obviously, cattle love grass, but they have a much broader dietary depth, and they'll freely eat perennial herbs, forbs, as well as young woody vegetation like young cottonwoods and willows. which can be important in riparian areas. So again, how do these differences in diet scale up to impacts on the ecosystem? Again, there's been some cool work done on this. This is from a study out of Kansas at Kanza Biological Station, where they've had bison on that landscape for decades now. And the plots you're seeing on the right, the first one is grass cover over time in areas with bison, cattle, and no grazers. You can see that annual cover of grass is declining over time in areas with bison, remaining relatively stable in cattle, and increasing in areas where grazers have been removed entirely. Going down to the second plot, and we look at this is native species richness. So the total number of native plants present on a given plot over that same time period, that diversity is increasing substantially in areas where bison have been restored, remaining relatively stable in areas of where cattle are present and where grazers have been removed entirely. This is a fairly similar story here in Montana. This is a study by Nate McMillan that was done out at American Prairie back in, I think the actual work was done in something like 2016. They found that species richness of native plants was higher in areas grazed year-round by bison than those grazed seasonally by cattle. And beta diversity, that is the diversity between individual study plots, was also higher in areas grazed year-round by bison compared to those with cattle and grazers removed entirely. So this is kind of where my work or my team's work comes into play. So as I said, I arrived in 2018, and my background was the study of avian ecology, or birds and bird diversity. So I was really interested in understanding, in places like that we had the privilege to work, like American Prairie and the Fort Belknap Reservation, do we see differences in bird communities in areas that are grazed year-round by bison versus those grazed in the traditional way seasonally by cattle? And interestingly, in the first habitat type we looked, which was the uplands, so this is the dry mixed grass prairies and sage steppe that kind of forms a mosaic in that part of the state. We found that grassland bird communities and abundances were basically the same in areas grazed year-round by bison and seasonally by cattle. And this really showed us, and I think was a positive message for all the conservation practitioners in the region that, with proper management, at least in terms of upland birds, both cattle and bison were capable of creating really high quality habitat. Next, we investigated what we called, mesic and riparian areas. So mesic just means like a little bit wet, essentially, whereas riparian areas are, areas surrounding streams and rivers. And we know these areas are critically important to a huge amount of grassland wildlife, from birds to carnivores dispersing across the landscape to deer and elk that use them for movement corridors as well as shelter and obviously water. And we also know from a variety of work that mesic and riparian habitats are really heavily degraded across huge areas of public land in North America. So understanding the potential impact of bison on these areas was really important. So we took a look at these areas in a couple different ways. The first was we characterized vegetation characteristics of these areas using satellite data. And what we found was increased cover of both native forbs and grass in areas where bison had been restored and compared to areas with cattle. And we also found increases in woody shrubs like sandbar willow, peachleaf willow, and young cottonwoods in areas where bison had been restored. The next step was to understand the impacts of those differences on the bird communities. And, no surprise, we found that with improving vegetation conditions, we saw higher abundances and higher diversity of birds occupying these riparian areas. And that ranges from everything to year-round resident birds like sage grouse and long-eared owls, to summer breeders like Baltimore oriole, yellow-breasted chat, and common nighthawk, to migrants that are just passing through in spring and fall, like Wilson's warbler, blue-headed or Cassin's vireo, and black-poll warbler. So taken together, this shows us that, bison restoration, when done in a responsible way, like by our partners American Prairie and Fort Belknap, really acts as sort of a passive riparian restoration strategy in mixed grass prairies. And when we step back another level and look at, the combined results from upland habitats and wetlands, I think of bison grazing as kind of a Goldilocks sort of situation. The grazing disturbance they provide in the uplands, in this case, has similar results as seasonal grazing by cattle and produces high quality habitat for grassland birds. While in wetlands, the fact that bison spend less time in those wetlands and graze less heavily on riparian woody vegetation results in major benefits for riparian vegetation and birds in comparison to cattle. All right, moving away from birds for just 1 second. This is something that was just like so interesting and tantalizing to me that I wanted to share it with you all. This is preliminary work done by a colleague of mine named Ellen Welty, who's now at Kansas State University. And she is primarily studies insects and is interested, like me, in the differences in insect communities between areas grazed by bison and cattle. And the details of this plot are not important. Each one of these dots basically represents a community of dung beetles, which is the species group that she chose to study here, which, despite the fact that some of you might find them a bit gross, they are incredibly important for things like nutrient cycling in grassland systems, where they're basically taking nutrients in the form of animal dung from above ground and sequestering it underground, which is a really important process. So each of these little dots represents a dung beetle community, and you can see the dots in blue are bison. The dots in green, I'm going to say green. I apologize, I'm colorblind if that's not green. I'm very sorry. You can see that they occupy different space. So all you need to know is that these communities are by and large different from each other in areas grazed by bison and cattle. And the cool thing is, and I had no idea this was the case before she did this work, but we have a lot of non-native species of dung beetles, just like we have non-native grasses, just like we have some non-native birds, we have non-native dung beetles in North America as well. And those non-native species were much more prevalent in areas grazed by cattle than they were by bison, where there were more native species of dung beetles. I just found that fascinating. Okay, so next I want to talk about prairie dogs, the sort of small and maybe slightly more underappreciated grassland keystone species in this system. So, bison may be iconic, but prairie dogs are maybe my favorite animal on the entire prairie. Their effects on the ecosystem are incredibly diverse, and frankly, they're just underdogs. I grew up in Rhode Island on the sort of Boston side of the Yankees Red Sox rivalry, so I just have this natural affinity for underdogs in general. And the other thing is, I want to say up front before I go more in depth in this section, that most of the prairie dog work that I'm going to talk about here was led by a phenomenal colleague of mine, Andrew Dreeland. Some of you may know Andrew. Andrew did his Ph.D. with us and recently landed a new job conserving grasslands with Palmer Land Trust or Palmer Land Conservancy in Colorado. So to start off this section, and as I alluded to before, I just want to say, prairie dogs have it rough. They've experienced somewhere between a 92 and 98% overall decline since Euro-American expansion into the West. And now on top of that, sylvatic plague, for which fleas are the vector, was introduced to North America around 1950, which has major negative effects on prairie dog colonies. When a colony is experiencing what's called an epizootic outbreak of plague, we often see something like a 90% decline in the prairie dog population, a 90 to 95% decline in the prairie dog population for that town. In addition to that, prairie dogs continue to be persecuted by humans. Around 55,000 individuals were killed by USDA Wildlife Services between 2009 and 2011. And in many states, including Montana, prairie dogs, and I find this sort of hard to digest, but prairie dogs are listed as both a species of greatest conservation need in state wildlife action plans, while simultaneously having the designation as an agricultural pest, which means that these animals can essentially be killed in any number at any time of year to support the agricultural economy. And this is critically important because prairie dogs sit in the middle of this incredibly diverse network of interactions among grassland species. Prairie dogs are food for a variety of predators, from black-footed ferrets, which we all know very well, to coyotes, swift fox, badgers. They perform these really important roles like grazing and clipping vegetation, which has the potential to sort of arrest woody encroachment onto grasslands. They construct burrows that are used by burrowing owls, ferrets, badgers, even snakes and spadefoot toads. And the potential connections go on and on. So prairie dog conservation really is a critical issue for grassland biodiversity. So this was some cool work done on prairie dog bird associations by Andrew in collaboration with our team. And the graph that you're showing on the left, I know the names of the birds are too small to read, but what I want you to take away from this is that species that have a lot of blue bars next to them have strong positive associations with prairie dogs. That means that they're either found more frequently in prairie dog towns than areas without prairie dogs, or they're found in higher densities in areas with prairie dogs than without. And there's many species that have positive associations, many species that have no associations, and some species that have negative associations. Some of the more, I guess, well-known positive associations with prairie dogs are species like mountain plover, burrowing owl, ferruginous hawk, thick-billed longspur, species that really prefer short grass habitats. And on the flip side, species that require tall, dense grass, like lark sparrow, uh, American pipit, sage thrasher, Baird sparrow, actually have negative associations with prairie dog towns. But the sort of holistic product of this phenomenon is that large grassland landscapes that have some areas in grassland without prairie dogs and some areas with prairie dog towns overall have the highest possible diversity of grassland bird communities. So going a bit beyond just associations between grassland birds and prairie dog downs, while doing this work, we thought we were observing something interesting. So another part of my work involves putting little GPS trackers on long-billed curlews and tracking their movements across the entire year. So our breeding birds in Montana, they nest here in Montana. They're here from April till around late July or August. And then they fly down to the Chihuahuan Desert of Mexico or the Gulf Coast of Texas. And we were really interested in those pathways to try to affect positive conservation outcomes across that entire landscape. But what we noticed looking at the movement data for when they were here in Montana on the breeding grounds, and each one of these little tiny colored pins that you see here represents an individual location of a long-billed curlew that was GPS tagged. We saw that their movement patterns tended to overlap with prairie dog colonies. The prairie dog colonies in this figure are these somewhat translucent white polygons. And it really seemed like there was strong overlap between areas that these curlews were using for foraging and active prairie dog colonies. And sure enough, we went in and analyzed the data, and that was the case. We found strong positive associations between long-billed curlews and both flat ground was kind of the number one thing they were looking for, but also active prairie dog colonies in our system, which was interesting. And it was somewhat contradictory to, I think, what you might expect. Prairie dog colonies can be these huge hubs of predator activity. There's coyotes, badgers, all these things. Why would curlews want to spend time in these places when they're potentially dangerous? So we thought about this and we thought about this and we thought, well, maybe we're missing what's important here. Prairie dogs are incredibly vocal animals and they are constantly on the lookout for predators. They have a very highly evolved communication system. They have calls that indicate aerial predator is present. They have calls that indicate a ground-based predator is present, and they have all clear calls to let everybody else know they can go back to feeding. And we thought, well, what if the curlews are using these areas because they potentially have this built-in home security system. They can spend time doing what they need to do in terms of foraging and taking care of their young and just, keeping an ear out for prairie dogs to alert them when predators are near. So, well, this is a cool idea and everything, but how do we actually test it? So this goes back to long-billed curlews, and I'll try to play the video here for you. This is a nesting long-billed curlew, and we had a video camera on the nest, and this is what a nesting long-billed curlew looks like in a relaxed posture, a relaxed environment. It has its head up, it's looking around. As you can see, this particular bird has an amazing view. Mouth is open, it's panting a little bit because it's hot. This is what a normal, relaxed, unworried long-billed curlew looks like. But interestingly, long-billed curlews have a couple different postures they can adopt on a nest. When they sense danger, when they perceive a predator on the landscape, as you can see on this amazing bit of artwork by Nick Garnart at Smithsonian on the right, they can adopt scientifically we call it a cryptic posture, but in the field we just called it pancaking. They basically press themselves flat against the ground to become invisible to predators. So we thought, well, since we can observe this posture from a distance, maybe we can test this idea of whether they're picking up on cues from prairie dog alarm calls by comparing when they adopt this cryptic posture in the absence or presence of prairie dog alarm calls. So to take this experiment a little bit further, and Anne alluded to this in my bio, Andrew put together something we call the badger-nator, which is a taxidermied badger. Was not killed for this purpose. It's already taxidermied, and we borrowed it from a museum, and we mounted it to an all-wheel drive RC car. And then what Andrew did was he piloted this remote-controlled badger toward a curlew nest that we were already aware of. You can actually see the curlew nest at the bottom of this slide, amazingly well hidden, from about 500 meters away, getting closer and closer and closer. And we did repeated trials at each nest, one where we did it in the absence of any prairie dog alarm calls, and the other trial where we played prairie dog alarm calls for which prairie dogs were responding to an actual badger. And to our sort of delight, we found exactly what we had hypothesized. These curlews were adopting this cryptic pancake posture at 3 times longer of a distance when we played prairie dog alarm calls indicating the presence of a predator. So they were eavesdropping on these calls, picking up that information, and responding accordingly. This was really cool. It was a relatively simple experiment, but it described a really cool bit of animal behavior, and we had a phenomenal time kind of talking to the world about it. So if you're interested in this, there's from back in June, Andrew and I were on NPR shortwave as well as Science Friday, and AP was kind enough to do a nice write-up on the work. So I'd point you in those directions if you're interested. And final last tidbit on potential impacts of prairie dogs on grassland ecosystems. And I bring this up because early in March of this year, there was a 700,000 acre fire in grasslands and sandhills habitat in Nebraska. And this is becoming a pattern of these winter and early spring large scale fires in grassland systems. We think this is largely a result of changing climate, increased dryness, and increased heat over winter and in early spring. That combined with extreme wind events, creates these potentially massive fires in grassland systems at times of year where we wouldn't expect them. Now, Courtney Duchart, a colleague of mine, along with myself and a few other colleagues, we sort of dug into this idea that, prairie dog towns, because of the way they clip vegetation and keep sort of biomass of vegetation down at all times of year, they really have the potential to act as fire breaks in large grassland systems. And this, has two effects. Obviously, from a human perspective, reducing the acreage footprint of large fires like this is a positive with potential positive outcomes for human health and welfare. But it also, it creates this diverse mosaic of vegetation characteristics in grasslands when there's fire in the system. And this is just an example. We found several of these in the literature, going back and looking at fire footprints and footprints of prairie dog towns. But you can see here from the Gilbert Ranch fire in Montana back in 2024, that blue polygon is a prairie dog town, and the red is the outline of the fire footprint. And you can see that that fire spread from southwest to northeast and was stopped at the edge of that prairie dog town, which again I find fascinating and speaks to the sort of ubiquitous impact these animals have on the ecosystem. So finally, I've talked quite a bit about the sort of hardcore science of grassland keystone species, but I want to talk just a tiny bit about the restoration of native keystone species from a social perspective, as opposed to a strictly ecological one. So, whether it's elephants and large predators in the savannas of Africa, or grizzly bears and elk in the northern Rockies, we as a society we can experience, and therefore we can visualize these sort of wild places and wildlife. That keeps societal memory of these ecosystems intact. And because we can know and understand what an intact African savanna looks like, or a wild Rocky Mountain landscape in Glacier Park, we can also understand what's been lost when it is lost. And we can place a societal value on conserving these systems. Now, I'd argue that with very few and relatively small exceptions, we as a modern society cannot and do not fully understand what an intact grassland ecosystem looks like. So we can't value it, and we have a harder time advocating for its restoration. And having bison and prairie dogs, return to grassland landscapes can potentially be a remedy to that. And as a conservation scientist and as a Montanan, it's something that I truly wish to see. So with that, I'm more than happy to take questions, and I want to point you towards a QR code on this slide that will sign you up to the Smithsonian Great Plains Science Program mailing list, so you can keep up with the work that we're doing, and potentially other talks or education opportunities that our group is engaged in. So thank you very much, and I'm happy to take questions.
Thank you so much, Andy. It was such an interesting talk, and we already have a question here for you. The first question is, why do you think the non-native beetles are more likely found with cattle grazed areas?
Yeah, that's a great question, and I am like particularly ill-suited to answer it because um, I'm not an entomologist, but I have to believe that something about the dietary composition of bison, and potentially even the chemical properties of their dung is potentially just more suitable because it's co-evolved with the native dung beetle species. That's a guess, but I think it's plausible.
Okay, I'm wondering to myself, um, what historically can you roughly say was the range of prairie dogs throughout the lower 48? And where are they primarily found now? I'm guessing some few states in the West, or where?
Yeah, so black-tailed prairie dogs, they're the most widespread species, both historically and now, ranged all the way from the northern Chihuahuan Desert of Mexico up into the prairie provinces of Canada. So essentially, you know, within suitable soil types, the entirety of the Great Plains represented their historical range. Now, the vast majority of grasslands have been lost in sort of the eastern tall grass prairies. Those prairie dogs are extirpated from there. And, it's not that they're absent from any giant chunks of their range, I think, but the overall pattern is that their colonies have just been shrunk and shrunk and shrunk and shrunk and shrunk, and become smaller and smaller in number. So they just sort of occupy a much smaller percentage of the overall landscape than they did before. Um, an example is that, in Montana, for those of you who've been up in the north central part of the state near Fort Belknap and near American Prairie, there's stories of prairie dogs going all the way from the Missouri Breaks to the Little Rockies in a continuous prairie dog town. There was likely thousands of black-footed ferrets in that colony. And now, we have prairie dog towns in that area, but they're, you know, 100, 300, maybe 400 acres, and they're scattered widely across that landscape, just occupying a much smaller footprint than before.
Okay, thanks. Okay, our next question is, can you give us any kind of update on how prairie dogs are doing right now in Montana in terms of plague and distemper.
Yeah, so plague continues to be a major issue. Every year at least in the portions of Montana where I work, which is primarily in the north central part of the state, we have some percentage of towns, in a given year, it might be 5 or 10% that simply blink out because of plague. So that problem has not been solved at all. There's amazing scientists like Randy Matchett and David Eads at U.S. Fish and Wildlife Service who've been working on this problem for a long time, primarily in the service of black-footed ferret conservation. And what I can say is that group of scientists has come up with some cool ways to dispense basically anti-flea medication, using the same drugs that's in the flea collar that you might put on your dog, dispensing that using drones and ATVs on the landscape to try to inoculate prairie dogs against fleas and reduce transmission. But A, that's expensive, and B, I don't think it can be legally done yet by order of the FDA at large scale. So that's something that they're still working on. Um, I think a couple positive bits of news for prairie dog conservation in Montana. There are a bunch of organizations that are incentivizing prairie dog conservation on private lands. Nature Conservancy of Montana, through their Matador Grass Bank, is doing that work, which is really cool, incentivizing private landowners to conserve prairie dog towns on their own properties. And Montana FWP, I think just last year, signed on the dotted line a conservation easement specifically with prairie dogs in mind on the south side of the Missouri River. So that's an exciting development. And, if scaled up, could be something that really helps prairie dog conservation in Montana.
Okay, great, thanks. Okay, next question. Do groundhogs in the east in any way mimic the same benefits as prairie dogs in the west?
I think in a word, no. Not that they're not ecologically beneficial, but they're pretty different. So groundhogs in the east are cousins of our marmots here in the west that we know from high alpine systems. And if you know groundhogs or marmots, they tend to be relatively solitary, or one family will be here, one family will be there. One of the really cool and impactful things, about prairie dogs is that they exist in these massive colonies. So it's not just one burrow here or one burrow there. There's thousands and thousands of animals living together that have this genuinely large impact on the landscape. And I think that's one of the reasons that they're so important. So pretty different than groundhogs in that way.
Okay, cool. Okay, next question. In a recent talk, Matt Skoglund from North Bridger Bison pointed out that historically large herds of bison had a big localized impact on wet areas, but that impact can create unique disturbed habitat suitable for some bird species. And they're just wondering what your thoughts are on that.
Yeah. Well, I I don't know if there's like a particular study that Matt is referencing. I know he's doing cool work. I think that what we expect happened as a consequence of, these massive, massive, massive herds of bison is that they would have a very intense but short-lived impact on particular areas as they moved through. So, that could be in uplands, grazing an area very, very, very low and creating short grass habitat. In wetlands, it might be, creating some sort of an open area and riparian vegetation where these huge herds pass through. And I think there are ideas that bison likely created huge shallow wallows on the landscape, which is maybe what Matt is referring to. And there's the possibility that if you create a sort of compressed soil depression in a grassland landscape, the product of that can be sort of these shallow ephemeral wetlands. And, so potentially like things like migratory shorebirds or avocets or Wilson's phalaropes, or even things like blue-winged teal might be able to use places like that to breed. But frankly, I think this gets back to one of the points I was trying to make early on is that these animals were eradicated so quickly and at such scale, we simply, again, as Western scientists, we don't know. A lot of this is speculation.
Okay, great. What do you think the next tangible steps are in changing perspectives on prairie dogs and restoring them as a keystone species?
What do I think the next steps are? Well, as a quasi-federal employee, I don't do advocacy on specific policies and actions. So we can't do that. It's not our role. But what I can say is that, the more people that we can, get excited about prairie dogs, the better. And I think the more connections we can make from prairie dogs to species that everybody cares about, like grassland birds or black-footed ferrets or plain spadefoot toads, it's a bigger crowd of people that we can then pull in and create interest in prairie dog conservation. And because of the way our systems work, we need popular support in society for conservation actions to happen. And so that's the role that I try to play is, education and getting people excited about them.
Great, thanks. Okay, can you comment on prairie dog burrowing and cycling of soil nutrients, such as organic matter, deeper soil horizons towards the surface, and its link to grassland health?
Yeah, so I can't comment with any meaningful knowledge on like physical properties of soil and water perforation into the system. I frankly don't know. I'm sorry. What I can say, and this emerges from again recent work by a colleague of mine at Smithsonian, Ellen Welty, is through defecation and urination at the scale of a giant prairie dog town, those actions essentially act like fertilization, like fertilizer in grassland systems, so that even though the stature of the vegetation and the biomass of the vegetation on prairie dog towns is usually low compared to surrounding grasslands, the actual nutrient density in vegetation growing on prairie dog towns is higher than that growing off prairie dog towns. With that obviously has huge cascading effects on any herbivores in the system. And if we have hunters or just ardent wildlife watchers in the crowd, there's a pronghorn on the slide right now. If you go out to eastern Montana into the grasslands and you're interested in hunting pronghorn, go to the prairie dog towns. That's where they are because that, in part, because that vegetation is so nutrient dense.
Interesting. Okay. Any thoughts or data on whether other birds like mountain plover and thick-billed longspurs use prairie dog alarm calls also?
So the only other species for which we have actual evidence that they listen in on prairie dogs is burrowing owls. A study by, I'm probably going to get this wrong, I believe it was Mike Wonder, um, several years ago showed changes in, burrowing owl vigilance in the presence of predator alarm calls from prairie dog towns. We don't know about any of these other bird species yet, but it's something that our research group is really interested in pursuing.
Okay. Sort of going back to the groundhog versus prairie dog question, but someone's asking, how about ground squirrels? Are
Yeah.
they at all similar to prairie dogs or not?
Yeah, I mean, similar answer, right? I mean, there's some similarities, and we have some ground squirrels in the Great Plains system, and I'm sure their burrowing actions and their sort of role as a nice prey item are important for lots of grassland species, but they tend to occur at much lower densities, and are much less colonial than prairie dogs. So this, their ability to create this entirely novel habitat type in grassland systems is just not the same as prairie dogs. At least the ground squirrels that I'm familiar with in our region.
Right. Okay, great. I am looking now and last chance to get your question typed in here so we can ask Andy about it. If not, we are going to wrap up shortly. So, okay, here's just a comment. Great talk. Thank you. What is the next big ecological question about grassland species interactions that you would like to tackle?
Oh man. Well, something that we're already working on to go back to the grassland bird, prairie dog piece of this is, the question of why do some grassland birds like to be around prairie dogs when in theory it's such a dangerous environment. Andrew has already completed a bunch of the field work, and we're working on publications right now to understand do grassland birds that nest in prairie dog towns suffer increased rates of nest predation or decreased rates of nest predation compared to when they nest off towns? Um, and how does food availability uh, impact the growth of nestling grassland songbirds that live on and off prairie dog towns? Potentially if there's more insects on prairie dog towns, or those insects are easier to find for adult birds, they might be able to increase their delivery rates to their young, allowing them to grow faster, get bigger, and get out of the nest in better conditions. So those are two pieces that are coming up next from our team.
Okay, I'm back because I want to thank you again, Andy, for such an interesting talk. And I just want to invite people, if you're in the Bozeman area, please join us for our next event, which is in partnership with the Bozeman Doc Series. The Doc Series will be screening a special Earth Day film on Thursday, April 23rd at the Emerson Center for the Arts at 7 p.m. The film is called Nuisance Bear, and it was the recent winner of the Grand Jury Prize in the U.S. documentary competition at Sundance. And come early at 6 p.m. because there's a lot of free food there and a silent auction going on before the film at 7 p.m. And then next, I also want you to mark your calendar if you're also in Bozeman area for our exciting Earth Day Festival. Again, it's on Saturday, April 25th at the Gallatin County Fairgrounds. It starts at 10 a.m. and goes till 2 p.m. But we also have a 5K Earth Day Fun Run, which is at 9 a.m. at the fairgrounds. And we're partnering with the Bozeman Winter Farmers Market. You can get all sorts of great local produce there, and that opens at 9 a.m. Also. The Earth Day Festival includes something for everyone. There are children's activities, which include our great Earth Day Magic Show backed by popular demand. It's at 10 a.m. Random Acts of Silliness has a drop-in storytime booth. There's face painting, a petting zoo with miniature horses. There are Earth Day educational games, and all kids win a prize, and they can put in for a great grand prize of a huge stuffed bison, which goes along with our talk tonight, or a huge stuffed wolf. And we also have over 45 exhibits, live music, and a great local foods pop-up food court. Of course, the city of Bozeman will be there with their cleanup week or day kits you can pick up. And we have three great talks, one about composting and one about how to be water wise and how to landscape for that, and a live raptor presentation at 1 p.m. So we hope you can join us for one or more of these future events. And I want to thank you again for coming, and look for our email, which will be in your email box tomorrow, with some additional great information about what the Smithsonian is doing, and also with a link to the recording. So thank you, good night, and take care. Thanks, Andy.